I was just mentioning that for those of you that emailed me saying that you want to start working on stuff right now because it's 7 weeks before Trinity term starts or whatever, you can start right now. I'll give you some molecules to work on at the end of this session, okay? Everyone else, you can start whenever you want. People who stay longer, like at least several months, may be invited to join other projects. And that's because as time goes on, okay, if I see you have really good skills in a certain area, like you're really good with Python, or you're very good with Slurm, or you're very good at something, then there's other projects I'm working on, right? Genomics, quantum computing, pure mathematics, astrophysics, astrobiology. So maybe there's one day when I might be like, oh, can you do this quick calculation for us? We're working on this paper. Do you want to contribute? But that will usually be over time, not like right away. Right away, we're all just working on the GW100 paper. And I've got to change the slides. Why is it not changing? Okay, so strange. I guess they got reordered or something. Okay. All right, so the first step would be to try to install PySCF. That's a Python program for solving the Schrodinger equation. It's really easy to use. So there's installation instructions over here. You can try running your first input file here. This is just input.py. That's the file name. You can run that file and it will solve the Schrodinger equation for the neon atom. That's 10 electrons, small calculation. You can do it on your laptop. Then I'll give you, if that works, if it doesn't work, you can let me know, or you can say something in the Discord channel and one of the other 25 people will help you, okay? If they figured it out themselves. Now, I'm going to assign molecules to people who are interested in contributing to this project. And, you know, some molecules might be more challenging than others. So I'm not going to pick and choose this very carefully. I'm just going to choose people randomly, or just in order of how you appear on my screen. And I'm just going to assign molecules one by one. And I just want to say that, okay, these slides are out of order now somehow, but the next thing I wanted to show was this one, yeah. So the Z matrix. So here you have just an atom, neon. Its X, Y, Z coordinates are just 0, 0, 0. If you have a bigger molecule like this C2H2, this Z matrix format, this is what the Python program needs. In order to solve the Schrodinger equation, it needs to know the geometry. How far away are the electrons and protons? Mainly the nuclei, how far away are they from each other? Because forces depend on the distances, right? Your repulsions and attractions depend on how far away the atoms are from each other. So the program needs to know the geometry of the molecule. For C2H2, you would give it the first atom carbon. The second atom is also carbon. It's attached to the first carbon atom with this distance, with this bond length, RCC, the carbon-carbon bond length. Then there's also a carbon-hydrogen bond length. So the hydrogen atom, the first hydrogen atom is bound to the first carbon atom with this bond length, RCH. The next hydrogen atom is bound to the second carbon atom with the same bond length, RCH. Now these are angles. I have the first hydrogen atom is bound to the first atom, which is carbon, and it is bound to the second carbon atom. And now we have 3 atoms here. We have hydrogen, carbon, and another carbon. So we have 3 atoms, those form an angle. That angle is here, 180 degrees. Then here, again, our second hydrogen atom, it's connected to the second carbon atom with this bond length, and the first carbon atom, that forms 3 carbon atoms. We now have another angle, A. Now, what's this over here? We have 4 atoms here. Hydrogen is bound to the second carbon atom. It's also bound to the first carbon atom. And It's also associated with the third atom, which is another hydrogen. There's now 4 atoms, hydrogen, hydrogen, carbon, carbon. These form something called a dihedral. That dihedral is also 180 degrees. So you have angles, dihedrals, and bond lengths. I will give you the data. I'll give you some bond lengths and angles, and you'll have to figure out how to make this Z matrix for that molecule that I assigned to you. And then you just run the Python program and you solve the Schrodinger equation. It's going to be easy. You'll be able to do it on a laptop. And then when we get to doing 60,000 of these or 10,000 of them, we start doing bigger molecules and stuff, you're going to have to use the supercomputers, which I will show you how to do. So there's another, this is an example of a bigger molecule. This is C6F6, basically benzene with the hydrogens replaced by fluorine atoms. And again, you just have bond lengths, the carbon-carbon bond lengths. And in here we have a ghost atom called X, which is in the center, just helps us make this Z matrix easier. And we have a bunch of bond lengths here between the ghost atom and the fluorine. And those bond lengths are all equal to this or that, but whether it's carbon-carbon or the fluorine atom. And then you have this bond angle of 60 degrees, and then you have a dihedral of 180 degrees. And luckily, we don't need more and more and more angles as we have more and more atoms. The angles, dihedrals, and bond lengths are all you need in order to specify the geometry of the molecule. Okay, so now there's something wrong with my slides. They're not going in order anymore, but maybe if I escape this and restart it, slideshow. Yeah, I don't know why it's not working. What I will do is I will just show you the final slides over here. Oh, maybe that was the final slide. No, I had another slide and I know it. Yeah, this slide. I wanted just tell you a little bit about the future. By the end of this project, what I think will hopefully happen for you, if my training is valuable to you, I believe that by the end you will hopefully have a lot of lifelong friends that are the best in your field. Okay, now all of these students here are from Oxford or Cambridge. I've seen some of the work that you've done on GitHub and some of the Python projects that some of you have shown. One person already has a publication. One person already has a publication in Surface Science or something like that. But there's definitely a lot of very impressive people here. I know that when I was at Oxford, it was hard to meet people outside of my college or outside of my department. But here you're meeting people across all colleges from Oxford and Cambridge. And 20 years from now, when you're a scientist working in a lab and you need someone who is an expert on solar cells or someone, one of the people in this group maybe will be working in that area, okay? That's at least what's happened with Richard and Emil. They have gone on to become friends and they met up with each other even without my presence. You will have some senior mentors. So myself, you might have seen Dejan Mihailov. He's at the Albert Einstein Institute in Berlin right now. He was a student at Oxford in physics and then did his PhD again in physics at Cambridge. And so he has a lot more experience than a lot of you do. And he's involved in this project. Vandan already has a master's degree. He works in electrical engineering, so he has expertise in areas different from me. So you'll have mentors in different areas and maybe reference letters. Like if you're staying in this project for a few months, then one day you might need a reference letter for something. And then there's senior people that have experience working with you, then that could be valuable. I think your resume by the end would have Slurm, Git, Unix, Linux, SSH, LaTeX, Lick, CMake, C4, MRCC, PySCF, which I showed you just now, VI, Vim, Fortran, Docker, Sphinx, Doxygen, JAX, HTML, CSS, JavaScript, PHP, SQL, all sorts of things. There's a ton of tools that we use in our work, and in my experience, the easiest way to learn these tools was to just use them. There's a project with a goal. We want to calculate the energy for 60,000 molecules. How do I do that? Okay, I need to use Docker because I can't install the software on my computer. I need to use a Docker image. Okay, then I just quickly download it and I figure out how to use it. Similarly, Slurm, I need to submit something to a supercomputer. And then how do I do that? Okay, does someone have a Slurm script they can send me? They send me the Slurm script and I modify it a bit to do my problem. And then now I've learned Slurm. All the work that we do is communicated to each other through Git. So, you know, when you're forced to use it, you learn it fast. You know, you can do a 9-month course on Git, and I'm pretty sure you'll learn less than what you will in 2 weeks with me. Okay, and when you have all these skills and maybe a paper published, you're pretty much guaranteed to be accepted into a PhD program. I showed you 3 of my students. There's also many more of them. 100% of them are now PhD students or already have PhDs. Okay, so I think that's my last slide, although these things got out of order somehow. So with that, I thank you very much for your attention. And I can do some assignments of some of these molecules for those of you that wanted to get started or just to like test the waters and see if you like this type of work. So you have the link to the PySCF software, the installation instructions. That's just the Python program you can install yourself. And then you can try that example calculation that I showed you, an input file for the neon atom. You can change it to involve the Z-matrix for these molecules. I'll assign these. So now I have to stop sharing, I guess, to see the people. Yeah, okay. I guess I'll stop sharing this screen. Pause share. Oh, stop share, okay. Okay, good, now I can see everyone, okay. And in Discord, is everyone in Discord right now? Okay, so in my screen right now, I will type out the names from left to right and assign, what's it called? Molecules to people if they're interested. So in the top left corner, I have Tommaso, then I have myself, then Harvey, then Shisun, Tanshik, Arpit, Rajna. This is just the order that I see people's names right now so that no one's gonna be complaining that, hey, you gave me a bad molecule, because I'm just doing it in order. Rose. And now I already saw someone leave, so that's good. We don't have to train as many people. Oh, wow, there's a lot of people here. Okay. Jim, Alexa, Deanne, and I did include Michelle as well. Okay. Good. Okay, those are the names in order, and now I'll just copy and paste these molecules. Hopefully I have enough molecules for everyone. I think I do. And I will give you the bond lengths and bond angles and all that, but you'd have to put it into Z-matrix format. So that's like the first exercise where, like, if you try to do that and like 2 days later you're like, oh, this is too hard, then that's where we get the first people quitting projects like this. Okay, so I'll just copy and paste these molecules, and I'll just, oh, Oscar. Oscar is typing, but Oscar's not in the Zoom room. So let's see what Oscar has to say. So the first one, okay, so yeah, the first molecule will go to Tommaso, the second molecule to Harvey. Does that make sense for everyone? Okay, and probably at this stage, some people might have some questions or comments, or I see everyone's typing. No one wants to talk. Do I have everyone accidentally on mute or something? You can.
Hi, is this just a question? My name on the list appears as number 18, but there's only 14 molecules. So
Okay, so I have more molecules here. Now this second list of molecules is a little bit, these ones are a bit more challenging. So here's a second list of molecules. Maybe I should have asked if anyone here is majoring in chemistry so I could assign some of these more challenging ones for them. So is anyone here majoring in chemistry? No one here is majoring in chemistry. No one here is studying chemistry. I already know one person that left already is majoring in chemistry. But okay, Mia. Is it Mia or Maya? Okay, so chemistry majors might, because I think most chemistry majors will know what dihedrals and angles and all this are. So yeah, so you said there's only 14 molecules. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 14, but there's 18 people. So anyway, okay, so Mia, is it okay if I assign you one of these more challenging molecules?
Yeah, that's fine.
Okay, yeah, so I'll edit this post on Discord. I'll say this one is already going to go to Mia, and there's only one person from chemistry here. I know that there's also one person that said that they had to leave is also in chemistry. I know that. So I'll type her name there too. And okay, since there's 18 of them, and there's 18 people here, and there's 14 molecules. Dayan, how about you didn't major in chemistry, but you have about 10 years of research experience. So maybe I could give you one of these harder molecules.
Sure, go ahead.
Okay, and Vandan is Vandan is still here. So if this becomes too hard for anyone, just type in the chat in Discord. There's 25 of us in the GW100 channel. You can just message, and someone's going to be awake, and someone can maybe help you. All of these molecules are actually not that hard. These are like 20 atoms at the most. When we get to GW60,000, we're going to be doing some hard molecules. Okay, so maybe I'll just put Vandan's name there since he's already graduated. And so then I think now with those four, that's 15, 16, 17, 18. So now everyone has a molecule then? And I'll remove.
Hello, I'm 20th and I don't have a molecule right now, I think. I'm
You're
not sure.
20th. Alexa.
Yeah.
Okay, I'm gonna share my screen and I'm gonna use VI to fix this. VI or Vim, whatever you want to call it.
there's 21 names. I just said I was the 18th, but in total there's 21 people that you've written down.
Oh, I see. Yeah. Okay, perfect. Okay, so let's get VI launched here. And I'm going to share the screen again.
But also, I don't think I'm assigned a molecule as well, but I don't mind getting a harder molecule because I've studied a bit of this molecular geometry stuff in school and I know what dihedral angles are. So.
Oh, good. Okay, so I forgot to add your name there. Is that what happened?
No, my name is there. My name is there, but there are 14 molecules and I'm 17.
Oh, yeah. Okay. Like you don't each have to tell me that this is a problem. Like I know it's a problem right now. So I'm working on fixing it right now. So what I'm going to do is I'm going to share my screen. So you're going to see how I fix it in VI, which is one of the tools that I told you that we would be using here, right? Can everyone see my screen right now? Is it just a blank terminal?
Yes, Nikkei.
Okay,
Yes.
perfect. So I'm just going to fix this in VI. So where's the Discord? Okay, so I'm going to get the names. Okay, so I've copied the names. Did I miss anyone's name? In Discord, did I miss anyone's name? Okay, so no one's saying anything, so that means that I probably didn't miss anyone's name. Okay, let me get these final ones. Okay, so I think most of you, if you're used to using Microsoft Word or whatever, you can copy things horizontally, but you can't copy them vertically. So in VI, I'm just going to, I don't know how to use VI on a Mac. For some reason I chose to use a Mac today. Okay, X, that's just gonna copy this. And now I'm gonna copy horizontally. So now all the assignments are just made like that. And because I'm using a Mac, it didn't work perfectly. So I forgot where those were supposed to go now. So what's I'm missing C6, H5, N2. So that one is, so this shouldn't have taken this many steps, but the Mac doesn't have the end button, or at least this MacBook Air. So so I think that H was supposed to go over here. Is that right?
No, I think the H was the first one.
Oh,
The
it was
H-
the first one. Okay. So for that, I'm just going to do that. And now you see it's just fixed. Okay. Now we have to remove, so Mia will go over here. Haled wasn't there. Dayan. Oh, I should have done this before. Okay, so Dayan, you go here. And then I guess, yeah, who is the one? Sukrit, you wanted to do a more challenging one. We can do
Yeah,
this.
sure.
So now, how am I going to do this? I want to yank this line and put it at the bottom. But if I do that, I'm going to lose the molecule. So what I'm going to do is I'm going to press the capital D. I just delete everything until the end of the line. And then so I'm going to put that, and then I'm going to paste this over here. That's one way to do it. So then we get London over here. So we have 4 people. Haled left the room but said that she was interested. So we have then, so now only 3 people don't have molecules. Is that the case? There's still 3 people that don't have molecules, right?
Yeah.
Yeah, I don't have a molecule.
Okay. Well, when I say more challenging, I don't mean like much more challenging. It's just like there's a little bit more work to do for these molecules because the data, yeah, it's not that big of a deal. But anyway, like I'm just doing this randomly. So some people get lucky and some people get unlucky. So here you go. I'm just going to do this. I'm not going to choose favorites or anything. I'm just going to randomly, whoever's name showed up first just gets the first molecule on the list. Okay, so anyone unhappy with this? Okay, so now I have everything side by side. And that was thanks to using VI. I think if you were to use Microsoft Word or something, or Discord, you copy and paste and it all goes horizontally. But here you can do things vertically and horizontally. Now Ahmed is typing. Ahmed and Oscar were both typing. They're not in the Zoom room as far as I can see. I can see people are typing in Discord, but I don't know what they're saying. gonna look at Discord on my phone. Oh, Ahmed needs to leave now. Okay. Okay, someone's already done the calculation. So Michelle has already basically done C3H6.py and wants to push it to GitHub. So that's good. As I said, this stuff isn't that hard. It's like a warm-up exercise. And so Ahmed, did I get Ahmed's name? Yeah, Ahmed got assigned to C2H6. Oh, but that's Ahmed with an E. Not, okay, I spelled it wrong. Okay. All right, I think everyone got a molecule. Oscar was typing, but isn't typing anything now. I'll just copy and paste this now into Discord. There we go. Okay, now maybe some people have questions. Does anyone have questions?